Hello. Here we carry on with I think it's number 3 of short sections of instructions on the use of qtVlm for our coastal navigation course, who is using the program just for basic chart reading and plotting, because we primarily focus on paper chart applications. But this is also showing how we can do all of the plotting and piloting and various sophisticated things we can do more accurately on a paper charts. But here's a situation. We're using a training chart, and all of these charts are gone. All paper charts of this style from NOAA have been gone for over a year now. But we hang on to these because all the practice problems are made based on this chart. And so this chart was frozen in time in 1998. At which time the variation was, if we look here, I'm rolling my mouse, 19 degrees 45 minutes east. At this point, I'm rolling the mouse in. And then over here, what do we get? A little bit of a difference, 19 degrees 30 east and so forth. So what we've decided long ago is that for all of the exercises and quiz questions and everything else that we use this chart for, we use a fixed 20.0 degrees east. That's our variation. And in the workbook, here's the workbook we use. It has tons of practice problems based on that chart. And then if you look at the magnetic variation, here you see, to simplify, we use fixed degrees, 20 degrees east. It says it there. Then it also says it on just about every chapter as a reminder, and every quiz almost has that as a reminder, 20 degrees east. So one of the things we want to do now is set up the chart so that when we do electronic bearing readings, it's going to use the right variation. We want at 20 degrees east. We want to force it to be 20 degrees east. We don't want it being real smart and telling us the real values. And so you do that, a couple steps to that. We'll go up to this menu at the top. And again, we have a couple videos before this one. And on these early ones, it's good to check those out before in order. Boat settings, variation. And here we want, the intelligent one where it reads it from the World Magnetic Model. This is a sophisticated program. It can tell you very precisely what the magnetic variation is any place in the world at any time. And when you read it out that way, it's going to be right. If the chart or whatever source you have is different, then that source is probably wrong. But we're not caring about that now. We want to force the value, and we want it to be 20.0 degrees east. Okay, we're done. And now we come back, and so now we want to do is we want to test that we've done this right. It's always important when you do something like that on one of these charts to test yourself you do it right. Now let's use another tool. I'm right-clicking, and I'm going to choose Ruler Tool and go straight up, and at 20 degrees east, this should be 340. And what's it read? It reads 0. So this thing is still reading true. So let's go back. We missed something. Let's go back here. Charts. No, boat settings, variation. Here it is. Look at this. So you have two things to do. You force it to 20, and you tell it you want to read magnetic bearings. Right? So you have two steps, magnetic bearings. Okay, good. We do that. Then we know then we're doing things right. Now I go back to Ruler Tool and go straight up, and I'm getting what? 340. Okay, 340. All right, so that's set to magnetic. And that's set to magnetic. Now, setting aside that that's what we're going to do whenever let me do a range. Oh, I just did one. Let me do the Ruler Tool again. You see, this is telling us, it's telling us two magnetic bearings, although they're not going to be different here because we're so close, but they're telling us a great circle and the rhumb line. These are subjects, that difference we discuss later, but you see it's giving it's giving true and magnetic, it turns out here in that view, that display. Okay, escape. But the real value, we could click anywhere on this chart or go to Hong Kong or anywhere we want and right-click it and say, query the World Magnetic Model. See, so the actual value today in 2025 is 15 degrees. 15.3 degrees east. That's, or let's see if I go, let me go, what do I get right here, right at this guy, a magnetic model, 15.4 degrees east, you see? So it's sensitive. Okay, 15.4. So just as an exercise, let's look at this once. I'm digressing, doggone it, but can't help it. Look, so this is 19 degrees, 45 minutes east in 1998. And here's what it's telling us. This is like, suppose you got on a boat and it's got some old charts. So you're going to have to correct for what the real variation is on these old paper charts. And this says the variation's decreasing 6 minutes a year. Now the question, we know what it is now. It's 15 degrees, and something, 15.4, and it was that. So I just did a real quick on the envelope here, check, and then we're going to let it go. Let's just look at this, if you can see this here. Okay, 2025 minus 1998 is 27 years times 6 minutes. That's 162 minutes, which is 2.7 degrees, which is 2 degrees, 42 minutes. 1945 minus 240, that is 17 degrees 03 minutes. That's what we would guess if we pulled this chart out of a dusty locker, from back in the day, and now we had to guess what the variation was, and we'd be wrong by 2 degrees. Not the end of the world, but that's an interesting exercise to keep in mind if you're using old charts. It's especially true, you get up in Alaska where this thing is, where the variation is changing a lot more quickly, then you got to be more careful with this. Okay, so that's how you do magnetic bearings, and then you'll be able to read and do, if a lot of our exercises ask for magnetic bearings, others ask for true bearings. So you have to be careful what's what and be sure that you're reading the right thing. What else in this section? Using marks and, okay. So let's do this. The other thing I wanted to do was one of the powers of the electronic charts, and it's a sort of a subtle thing, is that normally when you pick any chart, new part of the world, you fly to Hawaii and then you got a chart, you don't know any of the places. So your first job, if you're trying to do anything or follow any instructions, is find the place. Now, normally the way we would do that, let's go into our book here, and I just randomly picked a few places like Davidson Rock. Let's see, where did it say David? Okay, so here's some kind of exercise that wants us to do something at Davidson Rock. Right? Other places say do something at Smith Island or Protection Island or, I saw Hind Bank, Trial Island, whatever. So let's say you need to find Davidson Rock. So let me first show how you would do this in the old days, in the traditional all-paper navigation days. You would go to the light list, let's see if I have that. I do have it. Go to the light list. Oh, it's right here, light list. And then, now this is a digital one, so I can do Command F, Davidson Rock, and it finds it. Otherwise, I just have to look. There is an index. There's an index to the, but that's interesting. It's only here once. Okay, well, anyway, we found this, Davidson Rock. And the way, you have to go in the course and read how you use this light list. It's not immediately obvious because the items are not alphabetical or not necessarily along the coast. They go by waterway and it changes, but we discussed that. But anyway, here's where Davidson Rock is. So you know right now that Davidson Rock is right here at that latitude and longitude. So you can go and find it. And so if you want to use electronic charting, we could go with our fingers and find this. Or you could go and put it in. But here's another thing that came up in the last little short video. Look at this strange units. That's a Coast Guard light list. They're telling us this is, wait, let me zoom in so you can see that. Where is that? That's 48 degrees, 24 minutes, and 47.829 seconds. Now, that's frankly nonsense. They do not know that to that precision would be my guess. definitely when it gets out to where they're buoys, right? They don't know a buoy like that. I mean, the chain is, much longer than that, whatever. Okay, so, but this is what it is. Now, we could do that. We could go, let's show just the use of the program a little bit. Command-C. I'm going to copy that. Then I'm going to go to the program, and I'm going to say new mark. Oh, no, wait a minute. I have to go first, cancel. We have to go into the units first. Configuration. Now, I may have done this in preparation for this video here. General, units, and we want, oh yeah, I did do it. See, normally you're going to be using degrees and minutes dot minutes, like 48 degrees, 13.7 minutes. Sometimes you're going to use decimal degrees, 13.5 degrees, something like that. Very rarely do you have to do this, but I'm going to just show an example of using this one. So I'm going to switch it to degrees, minutes, and seconds, say OK. Now I come back and say new mark, and I'm going to just put, for that time being, so I can copy it somewhere, I'm going to put that's the name of the mark, that's that latitude, whatever. And now I come back and I'm going to grab the longitude of it. That's the longitude. Well, okay, I'll take the W, but copy. Come back here, I'm going to put it here. Okay, we don't really, okay, that's all right. North. Okay, we got it. So this is 48 degrees. Now this is 24. And then what's the minute? The seconds. These seconds are like that. Command-C. And now I'm going to just come in here, highlight that. Command-V. Yeah, that's good. And then where's the longitude? 122. Okay. And then 122, 48. 48. And then the seconds are like that. So this is, well, you would just go with your fingers up and down the chart, but I just want to illustrate the use of these marks here. Command-V. So that's all got it. Okay. Oh, no, I didn't. Oh, I can see it right here, but I didn't. I can happen to see it, but let's suppose you didn't see it. Then what you'd want to do is look at the marks manager, and you would see that mark you put in there, and then you would say center on that mark, and there it is, like that, right? So there's Davidson Rock. Mostly here now being an illustration of how you find things on a chart the old-fashioned way. But otherwise, you would go, this is 48, you would go 24, then you go up here and draw a line, and then you'd come down there and draw a line. But when you're doing this digitally, you can do things like that and be extremely precise to see what they're talking about, if that matters. Now, let's get back to the actual modern way these things are done. This chart is a raster chart. It's totally stupid. It doesn't know anything. It's just a graphic image of it's a photograph of the paper chart. But I'm also running underneath that these vector charts. These are the new modern charts that are digital. And the digital charts know everything. They know where all the named places are located. And if I have one of these charts loaded, I don't have to be navigating on it, but if I have it loaded, then that knowledge is in this program. Now, not all programs work this way, but this, again, I say, a sophisticated program. So what we can do now is go back to shut this off and go back to our chart here. Now, with the fact that database of everything's in there, if I want to find anything, I do Command-F. Command-F. Davidson, Davidson Rock, and hit search. Oh, Davidson, Davidson. Now that doesn't save us from that sort of thing. Davidson Rock Island, okay, whatever. I just click that and say center on the chart. And you see that finds it immediately. There was other things in our book here that we used, like Brochi Ledge. That's a famous landmark in the Northwest waters here. So let me do that. B-R-O-T-C-H-I-E, Brochy Ledge, L-E-D-G-E, search, find it, center on it, whatever. Brochy Ledge, you see, like that. So that's done then. That's done. So we've added a couple little new pieces of information for getting started with the chart and working the exercises. The really powerful one is when you get a problem that says do something at a certain bay, protection island or something like that, then you can find it instantly with the search engine. And that is, let's see, that's a landmark search. Yeah, so that's all I wanted to do for now, and we'll move on to other details later.